In this video, we're going to look at three parts of logical reasoning. We'll look at conditional statements, counterexamples, and converses. Let's start with conditional statements. Here's an example. Notice the format, if something, then something. The phrase that follows the if is called the hypothesis. The phrase that follows the then is called the conclusion. To determine the truth value of a conditional statement, sometimes we can just use our intuition, but other times we really need to get technical with what we mean by truth value. Now here's an example. My intuition tells me this is false. If a rectangle has a width of 4 feet and a length of 5 feet, then its area is 30 square feet. But let's prove using logical reasoning why this is false. The hypothesis is underlined. The hypothesis must be true in order for a statement to be true. Even if I'm disproving a conditional statement, the hypothesis must be true. All right, now, there's no reason to believe why this hypothesis is not true. There could be a rectangle with a width of 4 feet and a length of 4 feet. Now, how about the conclusion? So the hypothesis is true. Let's think about this conclusion, right? The conclusion follows the word then. This conclusion is false because we know if the width is 4 and the length is 5, the area is 20 square feet. Therefore, the statement itself is false. All right, let's use a counterexample to disprove a conditional statement. Very important, I cannot stress it enough. In a counterexample, the hypothesis must remain true while the conclusion can be proven false. So here's our practice problem. If two angles are complementary, then they both measure 45 degrees. All right, my hypothesis is true. There's no reason why two angles could not be complementary, right? But is my conclusion true? Or could I find a counterexample? I believe the truth value of this statement is false because I can think of two angles which add together to equal 90 degrees, but which are not 45 and 45, like 80 degrees and 10 degrees, or 60 degrees and 30 degrees. That's why the statement is false, because I found a counterexample. All right, now the word converse. You simply switch the if and the then part of a statement. So let's take a look at this. Here's a conditional statement. If an animal is a bird, then it flies. Well, this is true because the hypothesis is true, right? We have no reason to believe that an animal couldn't be a bird. So consider an animal which is a bird, then it will fly. All right, there's special cases if the bird has a broken wing, but for the most part, this is a true conditional statement. Now the converse. If an animal flies, then it is a bird. Could you keep that hypothesis true? Could you think of an animal which does fly, but one where it is not a bird? The statement is false if you can find a counterexample. How about a butterfly? How about a bat? What about a flying fish? Okay, these are all counterexamples which disproves the converse of the original statement. All right, now let's determine the truth value of this. If x plus y is even, then both x and y are even. Well, let's think about it. Picture two even numbers, right? Like, I don't know, 4 and 6. When you add them together, you get an even number. So does that mean that this conditional statement is true? Remember, to be true, the hypothesis must remain true, but the conclusion can be proven false. Here we found a counterexample, where both x and y are actually odd numbers, yet the sum of those odd numbers is even. Determine the truth value of this statement. If an angle is a right angle, then it measures 90 degrees. Okay, so the hypothesis must remain true. The angle has to be a right angle. Could it be anything other than 90 degrees? No. This is definitely a true statement. Let's summarize what we talked about. Conditional statements are statements that are written in the form if something, then something. The hypothesis follows the word if. The conclusion follows the word then. The truth value of the conditional statement is false if you can find a counterexample. And by counterexample, we're talking about keeping the hypothesis true, but showing that the conclusion is false. Then you've found a counterexample and you have disproven the conditional statement. I hope this clarifies the terms conditional statement, converse, and counterexample. Converse being switching the if and the then. Thanks for listening.